We're on problem 84. On a company-sponsored cruise, 2/3 of the passengers were company employees and the remaining passengers were their guests. So we could say employees is equal to 2/3 of passengers. And I guess we could also say that guests are equal to 1/3 of passengers. Right? The remainder are guests. If 3/4 of the company employee passengers were managers, what was the number of company employee passengers who were not managers? Okay, so the second statement in at least the problem statement, it says if 3/4 if 3/4 of the company employee passengers were managers. So company employee passengers. So 3/4 of E were managers. If I read that statement, if 3/4 of the company employee passengers were managers, what was the number of company employee passengers who were not managers? So essentially they want to know what 1/4 of E is, right? This is what they're asking because they want to know what were the number of company employee passengers that were not managers. And if 3/4 were managers, 1/4 were not managers. So if we could figure out P, we would be able to figure out E, and we'd be able to figure out 1/4 E. If we were able to figure out guests, we could then use that to figure out P, which we could use to figure out E, which we could then figure out 1/4 E. So that's how we should be thinking about it. Not that we should be spending that much time on it. Problem number 1. There were 690 passengers. 690 is equal to P. Well, that we'd be done, right? Because E is equal to 2/3 P, and then we want to know what 1/4 E is. So then our answer is, so the non-manager employees would be 1/4 times E, which is just 2/3 times P times 690, and that would be our answer. So 1 alone is sufficient. And then statement number 2, there were 230 passengers who were guests of the company employees. So they're essentially saying that guests are equal to 230. And then we could use this information that guests are just 1/3 of P, so which is equal to 1/3 of P. And then of course from there you could solve. You could multiply 3 times both sides of the equation to figure out that P is equal to 690. 690, so this is the same information that they gave in 1, which was enough to solve the problem. So 2 alone is also sufficient. So they are each independently sufficient to solve the problem. That problem's confusing just with the language. Company, employee, manager, passenger, guests. Becomes very confusing. 85. In the xy plane, does the point 4, 12 lie on line K? Okay, this is interesting. So let me draw a line K, and I'll worry about the point 4, 12 later. So let's see. They say, let me look at the points that they do say lie on K. So if this is the x-axis, that's the y-axis. Statement 1 tells us that the point 17 lies on K. So the point 1, 7 lies on K. 1, 7. And then they also tell us that the point, that alone isn't going to let me know if the point 4, 12 lies on it. So 1, 2, 3, 4, 12. It might be up here. Right, this is the point that we care about. If you can see that, let me scroll down. 4, 12. So if the line looks like that, maybe it goes through, but the line could be like that. So statement number 1 alone isn't enough. Statement number 2 says the point -2, 2. So -2, -2, x is -2, y is +2. So they're saying that lies on it. Eyeballing it, it seems -2, 2. Eyeballing this line K, it seems like 4, 12 could very well lie on it. But we have to do a little bit of math to figure it out. So first of all, just statement 2 by itself doesn't help us because this line could go anywhere. You need 2 points to just know what the line is. And so how do we figure out if the point 4, 12 is on this line? Well, the easiest way to do it is to figure out the slope. Well, I don't know if it's the easiest way, but it's the way I would think about doing it, is to figure out the slope of the line, and then extend that slope here and see if the point 4, 12 lies on it. So let's see, what's the slope of this line? So when we went up 7 minus 2, so the rise is 5. When you go up 5, we went over how much? 1 minus minus 2, we went over 3, right? So for every 3 that you move over, you go up 5. That's the easiest way to think about it. So when we go from, we're going from x is equal to 1 to x is equal to 4, so we're going to the right by 3. And so we should be going up 5. So 5 plus 7, sure enough, is equal to 12. So if you just extend the slope, it does hit the point 4, 12. So both statements combined are, well, actually, you know what? I just wasted a lot of your time. Because we just have to know whether the data is sufficient to answer the question. We don't have to prove that the question is true. I've just proven to you that 4, 12 does lie on the line. But you could have just said, oh, well, you know what? Statement number 1 gives me a point on the line. That alone isn't enough to solve the problem. Statement number 2 gives me another point. And then at this point, if you're really, taking the GMAT and time matters, you just say, hey, I got 2 points for this line. 2 points is everything I need to know about a line. Once I know 2 points on a line, I can figure out if any other point is on that line. I'm done. Both statements combined are sufficient. You wouldn't have to do all of this stuff that I did, which would waste your time. But if you, just to prove to you that you could figure it out, I did that. But anyway, I have to admit I did waste your time a little bit. You should just immediately say, oh, I got 2 points on a line. Once I have 2 points, I can completely figure out if any other point lies on that line. 86. The length of the edging that surrounds circular garden K is, okay, so we have 2 gardens, it looks like. So we have circular garden K, and then we have circular garden, let's see, what does it say? Is 1/2 the length of the edge that surrounds circular garden G. So this is circular garden G. This is K. This is G. So they're saying the length of the edging that surrounds circular garden K is 1/2 the length of the edging that surrounds circular garden G. So we could say circumference of K, right? That's the edging that surrounds it, is equal to 1/2 the circumference of G. Fair enough. What is the area of garden K? Assume that the edging has negligible width. Well, a couple of things. If we know the circumference, we know the area, right? Because the circumference is 2 pi r, and once we know r, area is pi r squared. So if we can figure out the circumference of K, then we know its area. And likewise, if we know anything about the radius or the diameter or the area of G, we can figure out a circumference. If we know its area, we can use the formula area equals pi r squared, right? Pi r squared, to figure out what r is. And then once you figure out r is, you could figure out that circumference is equal to 2 pi r. So if you have any of this information, you're able to figure out any of the rest of it. So statement number 1 says the area of G is equal to 25 pi square meters. So let me write it. Area of G is equal to 25 pi. So immediately you should say, hey, if I know the area of G, I can figure out the radius of G. And if I know the radius of G, I can figure out the circumference of G. If I know the circumference of G, I can figure out the circumference of K. If I know the circumference of K, I can figure out the radius of K. And if I know the radius of K, I know the area of K. And you shouldn't have to calculate any of that. So this is enough. This is sufficient. Statement 2, and maybe I'll do that for you just to show you that it can be done, but hopefully it's making some sense. The edging around G is 10 pi meters long. So they're actually they're telling us that the circumference of G is equal to 10 pi. So this is even easier. They're giving us this. That means the circumference of K is 5 pi, which means that we can figure out the radius of K, and we can figure out the area. So this is also sufficient to solve the problem. And just so you don't take a word for it, let me just show you how quickly you could figure it out. If the area of G is 25 pi, that means that pi times the radius squared of G is equal to 25 pi. That means that the radius is equal to 5, right? Cancel out the pi on both sides. R squared equals to 5. It means the radius is 5. That means the circumference is 2 pi times this. So that means that the circumference of G is equal to 2 pi times 5, which is 10 pi. which is exactly what statement 2 told us. And then from there, we could figure out the circumference of k, which is half of that. So circumference of k is equal to 5 pi. And then we know that 2 pi times the radius of k is equal to 5 pi. Divide both sides by pi. We know that the radius is equal to 5 halves. And then the area of k would be pi times this squared. So it would be pi times 25 over 4. And we'd be done. But all of this was a waste of time. I just wanted to show you that once you have the radius or the circumference or the area of either of these, you're able to figure out everything else. And I'm out of time. See you in the next video.